Hello, this is my presentation for Physics 2212's Lab 1 Charged Tapes. The purpose of this lab was to charge pieces of tape and determine approximately how much excess charge results from this interaction. An overview of the results we found were that when two U-tapes are charged, they repel each other. U-tapes are attracted to negatively charged pens. We found that the charge on the tape is 2.64 times 10 to the negative 8 coulombs, and finally that the excess charge is about 1.65 times 10 to the 11 electrons. Three fundamental principles that we used were Newton's second law for gravity, which states mass times gravity equals force, Newton's third law that states for every force there is an equal and opposite force where there is no acceleration occurring in a system, and finally, Coulomb's law, which equals force to be Coulomb's constant times a particle charge squared, all divided by the distance between particles squared. Some assumptions we made are that air resistance is negligible and that there is no acceleration occurring in the system. We modeled our experiment to depict that tape as a point charge centered in the middle of the tape, and that charge is evenly distributed along the surface of the tape. Before the experiment, we learned from testing the charged tape with our hands and a negatively charged pen that the tape itself is positively charged. The tape was attracted to a pen that is stated to be negatively charged, therefore we know that the tape is positively charged because opposite charges attract. We also determined that a neutrally charged piece of tape would be temporarily become positively charged when next to a negatively charged pen. Before the experiment, we got these measurements as shown. In order to conduct our purpose, we held positively charged tape B in suspension and raised positively charged tape A up under tape B until we noticed a repulsion occur between the two tapes, measuring the distance between the two for the repulsion to occur. As stated in our assumptions, because there's no acceleration, we know that our force of gravity working in the negative y direction is equal in magnitude to our force from the electric field. Because of this, we can first find the force of gravity, then set that equal to Coulomb's law in order to solve for Q1, the charge of the tape. With some manipulation of our equations, we find that our tape is charged to be 2.64 times 10 to the negative 8 coulombs. Another thing we wanted to find was the number of excess electrons on our tape B. That is easily found by taking our charge from the last step and dividing it by the electron constant of 1.6 times 10 to the negative 19 coulombs. We are also able to find the number of atoms on one side of our tape and create a ratio of excess electrons to atoms. Some discussion questions to think about are what would happen if our understanding of charges were flipped and how that would affect our observations. Nothing drastic would change. Simply protons would become known as negatively charged and electrons would be known as positively charged. Opposites would still attract and likes will repel. Mechanically, nothing is changing. Another question to consider is why is it important to be careful in the handling of our tapes, and what happens when the charges come in contact with our hands or other objects? The more you handle something charged, the more electrons transfer from that object to your body, which causes the object to lose charge. You gain a slight increase in negativity over a large surface area, while the object becomes more neutral. Some possible errors could have occurred from mishandling of tape, as explained in the last slide, the negligence of air resistance, and inaccurately reading measurements of the tape dimensions or the distance between tapes A and B during the experiment. Finally, this is my Go script code and conclusion. As you can see under the display of my model of the charges, our predicted calculations match the hand-calculated ones, and the display shows how the forces would interact at the observation point, tape B. Tape B, the green charge, acts as the observation point, providing a gravitational force downward while also receiving an equal electrical force upward from tape A, the purple charge, equaling in a zero acceleration.